The ancient Egyptian calendar was a solar calendar having a fixed 365 days per year. Now the Earth revolves around the Sun at almost exactly 365.256,363,004 days, and unlike other calendars that have leap years, wherein the discrepancy is corrected every certain period of time, the Egyptian calendar does not compensate for the 0.256,363,004 of a day difference every year. This means the Egyptian New Year is observed one day earlier or slides back one day every approximately 4 years. The Sothic cycle is a period of about 1,461 Egyptian calendar years of exactly 365 days each, which is equivalent to about 1,460 solar years, averaging 365.25 days each. At the end of one complete Sothic cycle, the calendar, having 365 days a year, loses enough time that the start of its year or its new year once again coincides with the heliacal rising of Sopdet, Egyptian name, or Sothis, Greek and Latin name, which Egyptologists associate with the star Sirius. I said the Sothic cycle is about 1,460 solar years because the start of a new Sothic cycle depends on actual observation of the star rise of Sopdet falling on the day before the Egyptian New Year's Day, and the precession of Earth's equinoxes causes the date of the heliacal rise of stars to move forward slowly in time. For example, the star rise of Sirius was June 18 Gregorian calendar in 3500 BC, but was June 30 Gregorian calendar in 2000 BC, or an advance of 12 days in a period of only 1,500 years, which, by the way, is just 40 years more than the supposed 1,460 years Sothic cycle. Because of this, the actual observed period of the Sothic cycle should be less than the calculated and presumed 1,460 solar years. The Egyptians call the start of a new Sothic cycle a great or divine year, and it corresponds to the life cycle of the sacred phoenix or the Bennu of Heliopolis, which is a symbol of rebirth. Now the first month of the Egyptian calendar is Thoth, which is by name only the first month of the flooding season, which the Egyptians call Akhet. I said by name only because this becomes true solely at the start of the Sothic cycle, when the first day of the first month of Thoth starts on the heliacal rise of Sopdet. Most scholars agree that the Egyptian day began at dawn before the rising of the sun rather than sunrise, and the heliacal rise of Sopdet is cited during this time. Thus, the Sothic rise falling on the first day of Thoth marks both the end of the previous Sothic cycle and the start of a new one. The concept of a Sothic year comes to us via a Roman author named Censorinus. In 238 AD, he wrote that 99 years before, or in 139 AD, a great year began on the Egyptian calendar, which is based on the motions of Sirius, the dog star, and that it is 1,460 years long. Astronomical calculation definitely dates this heliacal rising to July 20, 139 AD Julian calendar. Theon of Alexandria, who lived a century after Censorinus, agreed with him and declared that the previous Sothic cycle began with the era of Menophress in 1322 to 1321 BC, or exactly 1,460 years before July 20, 139 AD. Armed with that information, the Egyptologists looked for a pharaoh named Menophress. They settled on Ramesses I because one of his other names was Menpetire. Since Ramses is credited with only a one-year reign, both he and the beginning of the 19th dynasty were initially pegged at 1321 BC, although it has now been revised to 1292 BC. The earliest record of the start of the Sothic cycle can be found in the ivory tablet of Jer, the third pharaoh of the first dynasty of ancient Egypt, whose capital was in Thinis. This heliacal rise was dated by Egyptologists on July 17, 2773 BC Julian calendar. However, this date is too late for Jer's reign, which is dated circa 3000 BC. And this is a big problem because the Sothic cycle was used for absolute dating of the Egyptian chronology, not just for the 19th dynasty under Ramses I, which I discussed earlier, but also for the 18th dynasty and the 12th dynasty. And if the Sothic rise calculation for Jer's reign is too late, then this means the Sothic rise calculation used for dating the other dynasties may be faulty as well. In my previous video titled Sothis is Aldebaran, the eye of Ra, and the red Sirius is Ayin, the eye of Horus, the two eyes of Taurus, I discussed in detail the imagery found in the ivory tablet of Jer as follows. Thus, in summary, the ivory tablet of Jer is telling us that the heliacal rise of Sopdet Isis, or Aldebaran, the sun disk of Ra between two horns, whose star rise signals the start of the flooding season, happened in the constellation Taurus, the stooping bull representing Apis, the son of Hathor, while Venus, the feather of Ma'at Isis, representing Horus, was between the two horns of Taurus on the day a new Sothic cycle started. The actual location of Thinis, the capital of the first dynasty pharaoh Jer, remains undiscovered, so I will be using the coordinates of the center of a total solar eclipse located in Egypt instead. This eclipse, I believe, occurred sometime during Jer's reign. Using Stellarium and setting the algorithm of delta T to Chaperon 2s and Chaperon 1991, the location at coordinates 27 degrees, 31 minutes, 57 seconds north, 33 degrees, 10 minutes, 59 seconds east, the date to May 15, 2817 BC, or negative 2816 in astronomical year numbering, and at 2:16 UTC, one can see the heliacal rise of Aldebaran. Setting the time at 2:34 UTC, one can see Venus rising from the horizon. According to Stellarium, its heliacal rise should have happened on May 21 still, or 6 days later. However, looking at Venus' visual magnitude at that time, it was already at 0.73 or below magnitude 1, which is the limit for naked eye visibility during a total solar eclipse and is similar to the day sky during early dawn. So it may be possible that May 15 was also the heliacal rise of Venus coinciding with Aldebaran, a not so common coincidence. Note also that the ivory tablet of Jer placed the Ma'at feather representing Venus below that of the son of Ra representing Sopdet or Aldebaran. This implies that the visible rising of Venus above the horizon followed that of Aldebaran, which was actually the case on May 15, 2817 BC. Setting the time at 15:33 UTC, one can see a total solar eclipse just 30 minutes before sunset, allowing Mercury to be visible during daytime. The center of the eclipse was and still is part of Egypt, and I believe this is the true location of Themis. Note also that this eclipse was positioned at the left side of the club of Orion, while Orion and his club was positioned at the left side of Taurus. Now look again at the ivory tablet of Gier. There, one will see a club at the left side of Taurus, or the stooping cow. Furthermore, at the bottom left side of the club, one will see a circle with an inclined cross inside. The club at the left side of the stooping cow in the ivory tablet is of course the club of Orion, while the circled cross symbol at the bottom left side of the club represents the solar eclipse which happened at the left side of Orion's club. This circled cross is below the Sun of Ra and the Ma'at feather, implying that the eclipse happened after the heliacal rise of both Aldebaran and Venus on that same day, and which actually was the case. Now note the arm and hand pointing at the club in the ivory tablet. This arm is the right arm of Auriga, which is also pointing at Orion's club in the sky. Auriga is often portrayed as a charioteer, and the square with 9 smaller squares inside represents his chariot on top of the circled cross, the eclipsed sun serving as its wheel. The chariot on top of a circled cross wheel is a very ancient symbolism. The 9 smaller squares inside the square chariot represents the 9 deities of the Ennead, namely Shu, Tefnut, Geb, Nut, Osiris, Isis, Set, Nephthys, and Horus the Elder, while the sun god Atum is represented by the circled cross. Now notice the falcon sitting on top of the 2 boxes joined or stacked together. The 2 conjoined boxes represent the conjoined twins Castor and Pollux of Gemini, and the falcon sitting on top of the boxes, or the foreground of Gemini, represents the falcon god Horus, who was represented by Mercury that day, and which momentarily appeared in Gemini during the time of the eclipse. Apparently, Horus is represented not just by Venus, but also by Mercury as well, which are the 2 planets closer to the Sun than Earth. I believe May 15, 2817 BC is the correct date of the earliest recorded heliacal rise of Sopdet, and was the Egyptian calendar's first ever New Year's Day. Note, however, that May 15, 2817 BC is about 44 years earlier than the July 17, 2773 BC date calculated for the star rise of Sopdet during Jer's reign based on Censorinus' account. And this is understandable. After all, almost 3,000 years have passed between the first recorded Sothic cycle and the time of Censorinus. Because the precession of the equinoxes advances the date of the heliacal rise of stars slowly over a period of time, the Egyptians cannot use a fixed period of 1,460 solar years to mark the end of a Sothic cycle. So the Egyptians must use another celestial sign to mark its end, and this marker should coincide with the star rise of Sopdet for the effect of the precession on both the celestial marker and the star rise of Sopdet to match. The celestial sign that coincided with the star rise of Sopdet in May 15, 2817 BC was the solar eclipse. And a solar eclipse coinciding with the heliacal rise of Sopdet can be calculated or predicted because it occurs regularly over a fixed period of time. The orbit of the moon is inclined with respect to the orbit of the sun, and a lunar node is either of the 2 orbital nodes of the moon, that is, the 2 opposite points at which the orbit of the moon intersects the orbit of the sun. A lunar eclipse can occur only when the full moon is near either lunar node within 11 degrees 38 minutes ecliptic longitude, while a solar eclipse can occur only when the new moon is near either lunar node within 17 degrees 25 minutes. Now notice the eye of Ra, a symbol of Sopdet, represented by the red solar disk. Below it, one can see a two-headed cobra named Wadjet looking at opposite sides of each other. I believe this two-headed cobra represents the two opposite orbital nodes of the moon, responsible for solar and lunar eclipses. In Hindu astrology, the two opposite lunar nodes are named Rahu and Ketu, and they are both represented as a snake. Because the moon has two lunar nodes located opposite each other, and because the synodic orbital period of the moon is about 29.530589 days, two successive eclipses, one lunar and one solar, happens consecutively and separated by about 14.7652945 days from each other, or half the synodic orbital period of the moon. So for the ancient Egyptian astronomers, a solar eclipse visible in Egypt on the same day as the star rise of Sopdet, or a lunar eclipse visible in Egypt about 15 days earlier, should be the celestial marker they are looking for to declare the end of the current Sothic cycle and declare the beginning of a new one. A lunar eclipse visible in Egypt using the same coordinates which I used for Jer's Sothic rise observation was observed on May 8, 1385 BC at 21 UTC, or about 15 days before the heliacal rise of Sopdet on May 23 at 2 UTC of that same year. And this is why the Egyptian astronomers declared May 23, 1385 BC as the end of their current Sothic cycle and the start of a new one. This new Sothic cycle started during Menophthes' reign, according to Theon of Alexandria. I discussed this topic in detail in my previous video titled May 15, 2817 BC was the start of a 523,046 days Sothic cycle, and the Sothic rise during Menophthes' era was on May 23, 1385 BC. Now recorded dates of the star rise of Sopdet with their corresponding Egyptian day, month, and season, as well as the regnal year of the pharaoh at the time of the heliacal rise, were discovered, and Egyptologists use these to have absolute dating of those observations and therefore the dates of the regnal years of their corresponding pharaohs as well. The kahun or Ilahum Papyrus was found in the temple of Sirius II, and it says, "You know that at dawn will rise Sopdet on the 16th of the 4th month of the season of Peret." The name of the king is missing. However, Sirius III, also known as Senusret III, is associated with the text on the basis of comparing the handwriting of this text and the handwriting of other texts found at the same place, which do contain the name of Sirius III. Egyptologists date the reign of Senusret III at 1878 to 1839 BC, which means they believe his reign came before the second Sothic cycle that started in the era of Menophthes, and which Theon of Alexandria dated at 1322 to 1321 BC. Because of this, I will be using as reference the date of the first Sopdet rise that happened during the reign of Jer, and which I dated at May 15, 2817 BC. I discussed how I came up with this date in my previous video titled May 15, 2817 BC, the start of a 523,046 days Sothic cycle, and May 23, 1385 BC, the Sothic rise during the era of Menophthes. The fourth month of the season of Peret is Hormuti, which is also the 8th month of the Egyptian calendar. Each Egyptian month has a fixed 30 days duration, so that the 16th of the 8th month of Peret is also the 226th day of the Egyptian calendar. In other words, the 16th of the 8th month of Peret comes 139 days before the 365th day of the Egyptian calendar year. Now, the Egyptian calendar has a discrepancy of 0.256363,004 of a day every Egyptian calendar year. This means for the date of the Sopdet rise to slide 139 days backward, it would take 139 days divided by 0.256363,004 of a day discrepancy every Egyptian calendar year, or about 542.199919 Egyptian calendar years. Since each Egyptian calendar is exactly 365 days long, 542.199919 Egyptian calendar years are also equivalent to about 197,902.97 days, or exactly 197,903 days. 197,903 days are the number of days after May 15, 2817 BC, or the date for the Sopdet rise during the reign of Jer, which will give the 16th of the 8th month of Peret as the date for the Sopdet rise. And a date calculator shows that it falls on March 14, 2275 BC. This date is way too early for any pharaoh of the 12th dynasty and is more likely the reign of Pepi II of the 6th dynasty instead, according to current Egyptian chronology. For this reason, I will now calculate the date of the Sopdet rise of the Ilahum Papyrus with the assumption that the pharaoh ruled after the era of Menopres, which I dated to May 23, 1385 BC. The heliacal rise of Sopdet happens once every year, and yet only a handful of documents that recorded the heliacal rise of Sopdet with their corresponding dates and the regnal year of the pharaohs were found. The reason, I believe, is that the Egyptian astronomers only record the dates of Sopdet's heliacal rises whenever an eclipse, both lunar and solar, was observed in Egypt, either during the 5 epagomenal days or about 15 days before any of the 5 epagomenal days. The 5 epagomenal days are also known as the 13th and last month in the Egyptian calendar, and the heliacal rise of Sopdet happens on the 5th day. Also, the birthdays of 5 deities were celebrated during the 13th month, namely that of Osiris, Horus the Elder, Set, Nephthys, and Isis, and I ordered their names according to the order of their birthdays as observed during the Ptolemaic and Roman period. Now remember, 2 successive eclipses, one lunar and one solar, happen whenever the new moon or full moon are near the 2 opposite lunar nodes, which are separated by about 15 days of motion by the moon around the earth. And these 2 successive eclipses, occurring either during the 5 epagomenal days or about 15 days before any of the 5 epagomenal days, are caused by the 2 opposite lunar nodes in the same or almost the same position in the sky that marks the end of a Sothic cycle. The period of the intercalary month was considered spiritually dangerous, and the pharaoh performed a ritual known as pacifying Sekhmet to protect himself and the world from that god's plague. Apep was the ancient Egyptian deity who embodied darkness and disorder, and was thus the opponent of the sun god Ra and Isis Ma'at, representing order and truth. Apep was seen as a giant serpent, leading to such titles as Serpent from the Nile and Evil Dragon. According to his myth, Apep is responsible for eclipses. The 5 epagomenal days are already spiritually dangerous by themselves, but combining any of these days by an eclipse during or about 15 days earlier make these days especially ominous. This is why the pharaoh has to make a declaration that in spite of the eclipse, Isis Ma'at, represented by Sopdet, succeeded in its heliacal rise on the fifth day. One such eclipse, a partial lunar eclipse with an umbral eclipse magnitude of 70.3%, was observed in P. Ramesses with coordinates 30 degrees 47 minutes 56 seconds north, 31 degrees 50 minutes 9 seconds east. I will explain later why I chose this location as the observational site. The eclipse occurred on May 9, 845 BC, or negative 844 in astronomical year numbering at 045 UTC. You can verify this using Stellarium and by setting the algorithm of delta T to Chaffron-2 and Chaffron 1991. A corresponding solar eclipse occurred on May 22, 845 BC at 2354 UTC and about 14 days after the lunar eclipse that occurred on May 9, 845 BC. This solar eclipse was not visible in Egypt as it was below the horizon at that time, but it occurred on the first day of the 5 epagomenal days, or the birthday of Osiris, and it was an important omen to the ancient Egyptians. The heliacal rise of Aldebaran, which I believe to be Sopdet, was on May 27, 845 BC at 151 UTC as observed in P. Ramesses. Now what is the corresponding Egyptian date of the May 27, 845 BC heliacal rise of Sopdet as observed in P. Ramesses? The most recent heliacal rise of Sopdet, falling on the start of a Sothic cycle before this Sopdet rise on May 27, 845 BC, was on May 23, 1385 BC, which I already mentioned earlier. The number of days between May 23, 1385 BC and May 27, 845 BC are 197,239 days. Dividing 197,239 days by 365 days gives the number of Egyptian calendar cycles between these dates, which is about 540.3808219 cycles. Each cycle of the 365 days Egyptian calendar is 0.256363,004 of a day shorter than the actual length of the solar year, which is about 365.256,363,004 days. Multiplying 540.3808219 cycles by the 0.256363,004 of a day discrepancy per cycle gives about 138.533,650 days, or 139 whole days, which the calendar date of the Sopdet rise slid backwards from the 365th day of the Egyptian calendar. This means the heliacal rise of Sopdet that happened on May 27, 845 BC was the 226th day of the Egyptian calendar. Now each Egyptian month has exactly 30 days each, so the 226th day falls on the 16th day of the 8th month of Hormuti of the Egyptian calendar, which is also the 4th month of the season of Peret. And this is exactly what the Ilahum Papyrus said. So who was the unnamed pharaoh of the Ilahum Papyrus? In my previous video titled May 15, 2817 BC start of a 523,046 days Sothic cycle and the Sothic rise of Elephantine stele on May 23, 1124 BC, I dated the Sopdet rise in the 22nd and final year of Hatshepsut to May 23, 1124 BC. Since the Sopdet rise of the Ilahum Papyrus was on May 27, 845 BC, this means the Sopdet rise of the unnamed pharaoh came 279 years after the 22nd year of Hatshepsut. Using the current Egyptian chronology as my reference, this unnamed pharaoh should be Ramesses III of the 20th dynasty, with the Sopdet rise occurring in the latter part of his 7th year. Current Egyptian chronology dated the latter part of Ramesses III's 7th year to 1179 BC, while I dated it to 845 BC instead. This means Egyptian chronology of the 20th dynasty, at the very minimum, is 334 years too early. In one of my next videos, I will discuss how to correct this error. And as a final note, the reason why I chose P. Ramesses as my astronomical observational site for the Sopdet rise is because this was the capital of the 20th dynasty during when Ramesses III ruled. Also, Ilahum, where the temple of Sensret II is located and where the papyrus was discovered, is close to P. Ramesses.